Okay class, in our video today we're going to talk about angle bisector and perpendicular bisector. An angle bisector, first of all, is a line segment, and it is a line segment that bisects one of the vertex angles of a triangle. So here we have triangle ABC, and we're going to draw a line segment that is going to bisect angle B. So here what we will call BD is our angle bisector. Now if you remember, bisect means to cut something into two pieces, to two equal sections. So angle ABD is going to be the same as angle DBC. And then if we also think about our definition of a bisector, angle ABD plus angle DBC, when I put them together, is going to give me the whole thing, angle ABC. So that right there is our definition of an angle bisector. Now, just like with median and with altitude, we can have three angle bisectors in each triangle. So for example, here we have EG. This is an angle bisector. Here we have DH. This is also an angle bisector. And here we have FJ, and this is also going to be an angle bisector. Okay, so here we have three different angle bisectors. And notice once again, they all meet, or they intersect at a common point, another one of our points of concurrency. And this time, we call it an incenter. So remember, with median, when all three medians intersected, we had a centroid. When all three altitudes intersected, we had an orthocenter. And now when all three angle bisectors intersect, we have what's called an incenter. Moving on, now we're going to talk about a perpendicular bisector. And a perpendicular bisector does two things. First of all, it's a line segment. It has a definite beginning and a definite end. Perpendicular tells me that it's going to form a 90-degree angle, and bisector tells me that it's going to cut something in half. Now, as opposed to an angle bisector, a perpendicular bisector is going to cut a segment in half, as opposed to an angle. So if we're cutting a segment in half, it's going to go through the midpoint of one of these sides. So here we have our perpendicular bisector. The perpendicular part tells me it's going to be 90 degrees, and the bisector part tells me that it's going through the midpoint. So if M is my midpoint, that means this piece is equal to this piece. So not only is it bisecting ST in half, it's also forming a 90-degree angle. So this is what we call our perpendicular bisector. And in this case, it is MP. Okay? So M is the midpoint. SM is congruent to MT. SM plus MT is going to equal the whole thing ST. Again, that's that segment addition postulate. And because it's perpendicular, we say SMP is 90 degrees. This is kind of a combination of a median and an altitude. Remember, the median goes to the midpoint, and the altitude forms a 90-degree angle. So while this is not both an altitude and a median, it's kind of a combination of the two. It has those two properties, 90 degrees, and it goes through the midpoint. And just like with our three previous special segments, we can have three perpendicular bisectors in one triangle. So our first one, we'll call it RS, because S is the midpoint of BC, and it forms a 90-degree angle. We also will have BD, because this is the midpoint of AC, and it forms a 90-degree angle. And lastly, we also have LM, because M is the midpoint of AB, and it forms a 90-degree angle. So all three of those, RS, BD, and ML, are perpendicular bisectors. Now notice they also intersect at a common point, and like before, we have a special name for that. We call this the circumcenter. So remember, median was centroid, altitude was orthocenter, Angle bisectors form an incenter, and perpendicular bisectors form a circumcenter. Okay? Now if you notice, this time the point of concurrency, or the circumcenter, is on the outside of the triangle. That will happen sometimes with circumcenters, whereas our others were in the inside the triangle. A circumcenter can be both inside sometimes or outside. It just depends. So now let's do some practice problems. Our first practice problem says that KM is an angle bisector, which means it is cutting this angle into two equal parts. And so if angle 1 is 6x minus 10 and angle 2 is 4x plus 12, we know that the two pieces have to be congruent. That's what bisect means, cut in half. So now we have our equation, 6x minus 10 equals 4x plus 12. And we just need to solve. We're going to subtract 4x from both sides. And that gives us 2x minus 10 equals 12. Then we're going to add 10 to both sides. And when we simplify, we get 2x equals 22. The last step, obviously, is to divide by 2. Oops. And so our final answer is x equals 11. But it wants us to figure out what is the measure of angle LMG. Well, if you look, LMG is a combination of angle 1 and angle 2. So we're going to go find that angle 1, when we plug in, is 6 times 11 minus 10, which gives me 56 degrees. And angle 2, when we plug in, is 4 times 11, 44, plus 12 also gives me 56 degrees, which is what we said. If it's an angle bisector, these two angles have to be congruent, which is what we proved here. But to get the final product, LMG, we have to add angle 1 plus angle 2. So we're going to do 56 degrees plus 56 degrees gives me 112 degrees. So our final answer is 112. Now we're going to move on to our next question. So here we have our second practice problem. It involves a perpendicular bisector. We have triangle ABC where ED is my perpendicular bisector. And remember, a perpendicular bisector does two things. Perpendicular tells me that that angle is 90 degrees. Bisector tells me that we're cutting the segment BC in half. So D is the midpoint, which means this segment is going to be congruent to this segment. Alright? Now if that's the case, and we say that BD is 2x plus 4, in order to set anything up, we need to know what this side is, but we don't know that yet. The one thing we do know is that angle EDC, which is 90 degrees, is supposed to be 7x plus 6. So since we do know that for sure, I can set my equation up as 7x plus 6 equals 90 degrees. And I can solve from here. Subtract 6 from both sides. Simplify, and I get 7x equals 84. Then I'm going to divide both sides by 7. And our final answer is x equals 12. But again, we want to find the measure of BC. Well, now that I know what x is, I can go plug it in. And so I'm going to plug in, well, BD is going to be 2 times 12, which is 24, plus 4 is 28. And if this side is congruent to this side, then DC is also going to be 28. And if I'm looking for the whole thing BC, I'm going to take this piece, 28, and add it to this piece, 28. So BD plus DC is going to give me BC. So the whole thing is 28 plus 28, which equals 56.